We have the second part for law of sine. So in this case, we'll be solving for a missing angle. When you're solving for an angle, we do need to check your solutions because it is possible that we don't actually form a triangle. There's one triangle, there's actually two triangles, and that could be formed with the angle we know and the sides that we know. Usually that happens in the case where you have a triangle like this, and the same thing can be opened wider. So all that changes is this angle, and those sides can be slightly different. So since we're solving for angles, we're going to put our signs on top, and then down here we have our solution steps. So just like before, choose two fractions. One we have to know both values for, the other one we have to know one of the values for, to find the value of the sine. Then we'll use the inverse sine, so sine -1, to find the value of the angle, and then check the possible solutions. So the second triangle, if it can be formed, whatever angle we solve for, the other possibility is 180 minus our known the angle we just solved for. And then we check to make sure the triangle actually closes. So the triangle won't close if the two angles we have add up to more than 180, because all three angles have to add to 180. So if we have a number greater than 180, we can't solve, or the triangle doesn't, the sides don't work out. So let's look at some examples. Okay, so triangle RST, giving these values, find all possible values. So just like before, we'll start by, so RST, RS and T. So we know that little s is 3.5, little r is 5.4, big R is 49 degrees. Find all possible values for s. So we'll assume for now that there might be a second triangle. So we always have to make this assumption. Oops, no, T is, I don't know that. S is 3.5 and R is 5.4. So since we're solving for s and we know r, the fraction we know would be sine 49 over 5.4, and then sine s over 3.5. So we can kind of shortcut the math. So to get sine s by itself, we do sine 49 divided by 5.4 and then multiply the 3.5 across, but we can do that all at once in our calculator. So sine 49 divided by 5.4 times 3.5 gives us 0.4892. You probably want to carry 4 places there. So then to get it by itself, we do the inverse sine of that number. Now it's probably a good idea to just, when you do this, so inverse sine, and then if you use second and the negative key where it says ANS, it'll just pull your previous answer. Then you don't actually have to worry about rounding errors. So 29.3 degrees. So our first angle is 29.3. So the other angle, to get what this possibility is going to be 180 minus whatever our first S value is. So 180 minus 29.3. So 150.7. Now to check if our two angles we know add up to more than 180, the triangle actually can't form. So over here, 49 plus 29, that angle is definitely less than 180. So 29.3 is okay. Over here, 49 plus 150, that's like 199 degrees. So this triangle won't close because the angles are too large. You can only have 180 degrees in the triangle. So this triangle doesn't form, which means 29.3 is the only possible solution. So let's look at number 2 here. So we've got T, U, and V for our angles, little t, little u, little v for our sides. And then we'll assume we have a second triangle, T, U, V, and sides, little t, little u, little v. So little t is 560. And if you notice in the directions, whatever values are given up here, those have to be true in both triangles. V is 400 and V is 19 degrees. Find all possible values of t. So over here, we'll start with sine V over little v equals sine big T over little t. So sine t will be divide and multiply. So sine 19 divided by 400 times 560 gives us 0.4558. So then we do the inverse sine. So t is the inverse sine of 0.4558. And that goes in our calculator. So second sine, second negative to just pull the answer. gives us 27.1 degrees. Okay, then we come over here. So that's going to be 180 minus big T. So 180 minus 27.1 gives us 152.9 degrees. So over here, 27.1 and 19, that definitely adds up to less than 180 degrees. So that's our first possible answer. Over here, 152.9 plus 19. So these two together are 171.9, which is less than 180, which means my other angle could be 152.9. So this one has two possible solutions. All right, and our last one, so triangle F, G, H. So little f, little g, little h, maybe a second triangle, F, G, H, little h, little g, little f. All right, and then let's see what we know. We know that little g is 340, so that's true for both triangles. We know that little f is 240 for both triangles, and big F is 139. So that has to be true. So we're looking for possible values of g. So sine of the angle we know divided by its partner side equals sine of the angle we want divided by its partner side. So sine g would be sine 139 divided by 240, and then times the denominator on the other side. So 0.9294. So then g is going to be the inverse sine of 0.9294. So second answer. So little g is, or sorry, big G is 68.3 degrees. Is what we get there. And then over here, so this is going to be 180 minus big G. So 180 minus 68.3 is 111.7. So over here, 139 plus 68 is more than 180. That's almost 140 degrees, so this has to be no more than 41 in order for it to work. So that value does not work. Over here, those numbers are both over 100, so they definitely add up to a number more than 180. So this one would have no solutions. So these three values can't even form a triangle in the first place, let alone form a potential second triangle. So we have an example where you have one solution where just one triangle doesn't or adds up to more than 180. We have two possible solutions where both triangles add up to a number less than 180, or the third option where you have no triangles formed, in which case both sets of angles add up to more than 180 degrees. And that's the end of the section.